Okay, in this example, we are gonna explain how we are calculating the yellow time and the orange time for through movement and left turn movements. So basically, yellow time and the orange time uh, together, those form the transition period between the green interval and the red interval. Okay, so in order to do that, the yellow time allows drivers to make a decision whether to stop or to keep going and cross the intersection. The orange time allows vehicles that enter the intersection. Okay, for example, if a vehicle enters the intersection here with its front wheels, okay, it will have sufficient time to clear, then it turns red. So it's yellow. Once it, the front end of the front axle of the vehicle cross the line, okay, it turns red. Okay, the other opposing, for example, here, this is an opposing movement. It's not going to turn green until we make sure that this vehicle going this way crossed and cleared from the intersection. That's why we have what we call all red time. So this phase, this indication, still red, despite the fact that here is red, but both gets red until the vehicles inside this area, are cleared this the intersection. Clear on that? Let's go up here and just explain. So in order to calculate the stopping side distance, okay, or if we have a stopping side distance, we calculate it this way. Then the yellow time will be the stopping side distance divided by the approach speed. Okay, so it's basically the stopping side distance divided by B, we get the yellow time. Of course, we have here the stopping side distance equal V, which is the speed of the approach, multiplied with T PRT times per perception reaction time plus V squared, because V final, that's the V initial. The V final will be 0 because it's going to stop here, divided by 2G F plus or minus 0.01 G%, which is basically the grade of the road, if there is a grade. If it's level, then this is going to be 0. So that's for the yellow time. For the all red time, we are going to calculate the passing distance, which is basically, that's the passing distance plus length of a vehicle. So basically, the all red starts once the vehicle come here, okay? And, once the vehicle cross to this point, so basically that's from the front end to the front end, that's the passing distance or the width plus one vehicle length. One vehicle length, typically 4.5 meters. And V, that's the crossing or the approach speed. In this case, it should be the crossing speed. Okay. So that's for vehicles that are moving through. So this is for through movement. For turning movements, specifically for the V, for the vehicle making a left turn, okay, here the situation is a little bit different. The yellow time is basically the same stopping side distance, SSD, but it's divided by the approach speed plus the turning speed divided by 2, which is basically the average speed. Why? Usually, the turning speed is smaller than the approach speed, because vehicles are turning on a radius here, but it's not going through. So if that was maybe 80 kilometers per hour, okay, the turning speed might be 40 kilometers per hour, depending on the geometry of the intersection. So if a vehicle is, trying to make this cross, so is it gonna, you know, start with V and start slowing down until it reach V turning. That means this distance, the average speed for this over this distance will be V plus V turning divided by 2. So that's the average speed. Okay? So Vt, the speed, the turning speed, we get it from this equation, which is basically the square root of G, that's the gravitational acceleration, multiplied with R, that's the radius of curve, or turning curve, and the side friction. For calculating the passing distance, for calculating the ORED, it's basically the passing distance plus vehicle length divided by the passing speed. So it's this segment. So that's the passing distance. This arc, that's the passing distance. Plus 1L, so that's L arc plus L divided by V turning. Is that clear?
Yeah, that.
Okay. Then we go here to our example, or our, yes, our example, and let's see what we have. What we have here, we have a longitudinal friction, okay, and the turning radius, 50 meters, lane width, okay, and here also we have the arc, the turning arc, or the turning distance, 35 meters. We have a median width, 4 meters. They have approach speed, V, 60 kilometers. So basically, we want to calculate the turning speed. Okay. Okay. So let's first of all let's calculate the stopping side distance, because we are going to need it for both. The stopping side distance equal the speed is 60, so that's 60 kilometers per hour divided by 3.6 in order to be meter per second, multiply T PRT plus 60 divided by 3.6 square divided by 2 multiply 9.81 multiply 0.348. What is TPRT here? Can someone tell me? What is the recommended value?
I think it's 1.
1 second, exactly. So
Yeah.
this one is 1 second, because why it's 1 second?
According to Ashto.
According to the ITE, at signalized intersections, okay, we use a perception reaction time 1 second. Why? Because it's expected, right? If you are driving on a highway, it's not expected to have an accident suddenly. It's something sudden, as we say, correct? But if you are driving on a street and on an approach and there's a traffic signal, okay, we know by heart that this signal it can turn red at any time, correct? So there is expectancy for this stop. So let's calculate this. So it's 60 divided by 3.6. This would be 57. Okay, hold a second. Yes. So it's 57 0.35 meters. Let's calculate the turning speed, V turning. So V turning equal square root of G R F L. FL is basically the coefficient of friction in the lateral direction. So that's the side or the skidding coefficient of friction. Here we don't know what is the value for that friction, but we have this curve. If you remember, let me just copy this to you. You remember this curve? That's for the side friction. Okay, so where shall we start here? We can just start by assuming that we have a coefficient of friction, that the turning speed is 50, for example. So let's say let V turning equal 50 kilometers per hour. We're going to call this VT1. So that means the FL, the coefficient of friction here, will be 0.19. So this will be square root of 9.81 multiply R, turning radius is 50, 50 multiply 0.19. So this will be 9.65. So this will be 9.65 meter per second. So that means it's going to be multiply 3.6. So this is 34.75 kilometers per hour. So that means we are here somewhere. So that means this is our coefficient of friction, which is the FL2. So that was FL1 equals point 0.25, say. So VT2, that was VT1, equals square root of 9.81 multiply 50 multiply 0.25 equals. So this will yield us 30, I'm sorry. The result, okay, after multiplying by 3.6 and converting it into kilometers per hour, will be 39.86, which is almost 40 kilometers per hour. So here is the 40 kilometers per hour. So that means the new term, it's 0.225. So here we have LFL3 equal 0.225. So VT3 equal square root of 9.81 multiply 50 multiply 0.225 equals 37.82, which is almost 38 kilometers per hour. So 38 kilometers per hour is almost FL4, that's 0.2 I think it's something negligible. Okay, the change is negligible. So we are gonna give it this last try, or that this is gonna be our last iteration most probably. So that's a square root of 9.81 multiply 50 multiply 0.22, 0.223 or 0.23. So this will be, okay, this is 38.2, which is almost 38 kilometers per hour. Here we stop. Why we stop? Because the change, the delta in change is very small. Let's calculate the delta change equal 38.2 minus 37.82 divided by 38.2. Let's see the percentage of change here. How much is it? 38.2 minus 37.82 divided by 38.2 multiply 100. Let's see the percentage of change. So this is going to be percentage delta. So it's basically 0.99%. That means 1% change. When the change now or the improvement is just 1%, then we can just, stop there, and that's acceptable for us. Okay? So now we have the stopping distance, and we have the turning speed. What else we need to do? We need to calculate the, we need to calculate the yellow time for through movements and for, let's go for the through movements. So for the through movements, yellow time equals the stopping side distance, which is 57.35 divided by the approach speed, which was 60, but we need to convert it to divided by 3.6 to be meter per second. So here we have 57.35 divided by 60 divided by 3.6. So this is going to be 3.441 second. We take the highest. This is going to be 4 seconds. We round it up. Okay, we try to get the top of this. Then the all red. Okay, the all red, it says that the passing distance or the width plus length of one vehicle. So in our case here, what we got? We got here the intersection, one lane, second lane, fourth lane, fifth, third lane, fourth lane. And there is a median in between here. There is a median. So basically we have lane width 3.6. So we have 3.6 multiply 4 because we have 4 lanes plus one median, okay, which is 4 meters. So the passing width or the passing distance is going to be 3.6 multiply 4 plus 4. So it's 18.4 meters. Okay, so here the all red will be the passing distance plus vehicle length divided by the passing speed. That's the rule. So basically, the passing distance is 18.4 and the vehicle length 4.5 meters divided by what's the passing speed for the through movement? It's going to be 60 divided by 3.6. So if we calculate this, we end up with the following: 22.9 divided by 60 divided by 3.6. This is going to be 16.67. So this will be 1.37 seconds. Let's wait for this and see how we're going to round this. But most probably this is going to be up to 2 seconds. Now let's do the same calculation, but for the left turn movement. For the left turn movement, the yellow time equal the stopping side distance 57.35 divided by the average speed, which is basically 60 divided by 3.6 plus the turning speed, which is 38 divided by 3.6, and both. So this is going to be the numerator for this one. So basically this will be 60 plus 38 divided by 2 divided by 3.6. So this will be 57.35 divided by 13.611. So this will be 57.35. So here it's 4.2 seconds. Okay. So here, in case of the left turn, it's okay if we go with the 4 second, but I prefer that we go up to 5 seconds. The all red will be the same, the passing distance plus vehicle length divided by the passing speed. Here the passing speed is 38 divided by 3.6. So that's the turning speed. And I remember we had an arc length here. The arc length, assume that for left turn, L arc 35 meters. So we have arc length 35 plus 4.5, that's vehicle length. So we have 35 plus 4.5 divided by 38 divided by 3.6. So here the order time will be 3.74, which is almost 4 seconds order time. These values are, by the way, the yellow time and the all red times, these are critical safety issues for intersections. Okay, any questions so far?
دكتور الحين
Okay, now your question is, in this case, should we take the highest of all? You know, for the yellow time, should we take, maybe we have here 4 and 5, we take 5, and for the all red, we have 2 and 4, we take 4. That depends on the phases. So for example, if we have one phase, for example, that was like this. We have left turn, through, and right turn. In this case, you are right. You are going to take the yellow time and the all red time. The yellow time will be, in this case, for 5 seconds, and the all red time will be 4 seconds or 3 seconds. Okay. But if we have two separate phases, for example, if we have dual through phase and plus another phase, which is dual left phase, something like that. Okay. So in this case, the yellow time here will be 4 seconds and the all red time will be 2 seconds. Okay. And for this phase, it's going to be 5 and 4. Clear?
Clear, Doctor.
Okay. You know, it's not very common that you see these kind of phases here in the Eastern province. But I think if you go to Jibel or some intersections in Aramco complex, you might find some of these intersections. Clear?
Yes, Doctor.
Okay. Thank you. Any questions?
دكتور بالنسبة
Yes.
لطول الفيهيكلز هل دائما هي 4.5؟
Yes, it's, you know, it's approximate. So you can say it's 4.55 meters. Okay. But you can't, you know, for example, you know, something reasonable. That's the bottom line.
اوكي
Okay.